Okay, hopefully a pretty quick video here. We're going to start a little lesson on probability to finish up the year. Three quick things in this section. This is called permutations and combinations. But the first thing it talks about is what's called the fundamental counting principle. Okay, the fundamental counting principle says this is basically when you have different. I'll give you an example. It's hard to word this without giving you examples. Okay. If you have, let's say, 6 shirts, 4 pants, and 3 hats, and you want to know how many possible outfit combinations you have, the fundamental counting principle says you multiply all your options together. So 6 times 4 times 3 is, let's see, 24 times 3, that's 72 different outfits. Okay? Let's say that you are at like a sandwich place and they have 5 types of bread, 4 types of meat, and 3 types of cheese. Then to determine the number of sandwiches options that you could produce with these things, you would do 5 times 4 times 3, which of course would be 60 different types of sandwiches. So that's the fundamental counting principle wrapped up in a very short explanation. Okay, the next thing is permutations and combinations. Permutations and combinations deal with the number of options, again, that you might have of something. And these are when things can be arranged, okay? When things can be arranged. So a permutation this is the number of arrangements when order does matter. Okay, and a combination is the number of arrangements when order does not matter. Okay, so let's go through a couple situations when order does matter and when order doesn't. Okay, if I want to know how many people can finish first, second, and third in a race when there is 10 total racers. Okay, so 10 racers, how many ways can they finish first, second, third? Okay, well, that's a permutation because the order matters. Okay, if Bob finishes first and I finish second and Jerry finishes third, that's different than if I finish first and Jerry finished second and Bob finished third. That's a different outcome. Okay, now how does that compare to a combination? A combination might be, let's say there's 10 students and 3 are selected to student council. Okay, the order in which they're selected doesn't matter. It doesn't matter if you were selected first or selected second or selected third. You still made student council. Okay. So when you're just trying to select a group, and that group does not matter if it comes in first or second or third, then that's a combination. Okay. If the order in which they're selected does matter, then it's not. This is here. Let's do some examples. How about we have how about we have 15 horses. How many ways can you finish first, second, third? Okay, now I'll give you a style of thinking for permutations. First of all, order does matter because we want to distinguish finishing first, second, and third. I'll give you a style of thinking, and I'll show you how you can do this on your calculator. Okay, one style of thinking is to draw the podium. Okay, here's first place, second place, third place. and ask yourself, how many options of horses do we have that could finish first? Well, there's 15 horses, all of which could finish first. Okay. Now, once one of them crosses the finish line, how many options of horses do we have to finish second? Well, you can't finish first and also finish second. So there's only 14 horses left here to finish second. Same thing. Now we have a first place and a second place. There's only 13 options of horses that could finish third. So my answer would be I multiply all these together. This goes back to relating this to the fundamental counting principle. Okay, so 15 times 14 times 13, there would be 2,730 ways that they could finish first, second, third. Now, the other way to do this is a permutation. 15 choose 3. That's how you say this. Permutation 15 choose 3. Okay, your total goes here. Your choose number goes here. And this is a button on your calculator. You go to math, arrow over to probability. Okay, and here is my permutation button. I will put my 15 here. I'll put my 3 here, and we'll get the same answer as we did before, of course, 2,730. Okay, now, a combination. How about, how about 8 students submit artwork, 4 artworks are chosen. How many options? Okay, now, this is a situation you have to determine if order matters, okay? Order does not matter because no matter what, if I choose 4 works, okay, I'm just going to display those. The display doesn't change. It doesn't matter which display comes first, second, or third. It would still be the same 4 artworks chosen. Okay, so this is a combination. Okay, and now again, in your calculator, this is a combination. You put your total number in front and your choose number in the back. Combination, 8 choose 4. That means there's 8 total options. We're going to choose 4. The order does not matter. So again, I go math. I arrow over to probability, go down to this NCR, okay, which is your combination button. We have 8 total students. We're selecting 4 of their artworks to display. That is 70 different options. All right. I just need to practice to get good at these to determine if they're permutations or combinations.